We'll proceed in vector algebra and calculus. Vector algebra and calculus. So this is the topic that we are pursuing. Vector algebra and calculus. Okay, so when algebra came into the picture from the numerical science, the base of the mathematics is numerical science. 90% of the load that is mathematics take is numerical science. People who are very good in numerical science, they can only understand the algebra. Now, when algebra came, then people started saying that that algebra is the future of mathematics. Then people started seeing the kind of issues in algebra. Issues in algebra, people started feeling that it is not complete. Then in algebra, different coordinate system came into the picture. When different coordinate system came into the picture, then people felt that it is kind of complete now. Okay, post that when it became incomplete, then calculus came into the picture. But later again, people have started feeling that algebra and calculus is all right, but there is no direction. We don't know what is the direction of the computation. Then a vector came into the picture. Still, people felt that vector is not complete. Then algebraic vector came into the picture. That is also called vector field. Why algebraic vector is considered as future? The last thing that is in calculus is algebraic vector is in machine learning and artificial intelligence. Whatever the data we capture, set of data we capture, each data is represented as vector. So person who is very good in vector, person very good in algebra, coordinate system and calculus, he can take. But whatever, the prerequisite of mathematics is person must be very good in numerical sum. Must be. He understand underneath what is the numerical computation that is going on. Then only he can understand any set of mathematics. Anyway, now we are in vector terminology. What is a vector? I think many times I have demonstrated what is a vector. Vector is nothing but an energy source. Vector has different fundamental altogether from algebra. Vector is a different technology at all. Altogether it is a different technology that is a vector. So if I say that I have a vector I, consider this is x-axis. This is x-axis. This is origin. If this is the origin, then this is minus x-axis. This is x-axis. If that is the case, then this is y-axis and this is minus y-axis. Now there is energy called I vector. There is energy called I vector. I vector means energy which has a unit magnitude and its direction is along x-axis. This way energy is moving with a unit magnitude. Energy will have a power, how much power it contains and in what direction it is moving. So that is a vector. So if energy is moving along x-axis, then it is I vector. Consider 4I. 4I is the vector. Then it is moving along x-axis, but its magnitude is 4. Power is 4. I means power is 1. So a vector is coming from minus x direction and moving along x-axis. This is origin. This point is origin. In that sense, at origin, it comes into the picture. Now, from minus y-axis, another vector is coming, and that is j, moving towards positive y. Now, at this point, both vectors are meeting. If they are meeting at this point, then resultant will be a new vector. Okay, new vector that will move like this, one vector here and other vector here. If they combine, they will move like this. What is this vector? This vector is nothing but I plus j, because both energy, if they combine, that is combination of the energy. Certainly it will not be multiplication of the energy. Okay, so one vector whose magnitude is 1 and moving along y direction, and one vector whose magnitude is 1 moving along x direction, if at origin they meet each other, they flow in different direction altogether. That vector is nothing but addition of these two energy sources, that is I plus j. I plus j. I plus j vector is like this. If this is y-axis, this and this is x-axis, then I plus j vector is like this. If I plus j vector is like this, then what is the angle it is making with x-axis? What is the angle it is making with y-axis? What is power of this vector? So power of the vector is magnitude of the vector. So I plus j, magnitude of the vector is x square plus y square square root. 1 square plus 1 square square root. The square root of 2 is the magnitude of this vector. How come you can say like that? One vector has magnitude 1 and one vector has magnitude 1. If they get added together, then magnitude should be 2, right? No, because both are in different direction. If they are in different direction, their magnitude will not be sum of these two. No, no, I don't believe. You have to believe. Because if consider there is a vector going in this direction called I. There is another vector also going in this direction called I, and at origin they meet. Now they proceed and new vector is 2I. What is the magnitude of this? What new vector is I plus I? Because they meet at the origin. Now new vector is I plus I. What is the magnitude of this vector? 2. So if they meet in same direction, then you can add the magnitude also. Otherwise, this vector will get added like this, I plus j. Makes sense, right? If someone is moving in y direction and someone moving in x direction, when they collide, then they will move in separate direction. They would move in separate direction altogether. Okay, in that sense, magnitude, since they are at 90 degree to each other, how I can believe the way you are saying? Okay, you will believe now again. Consider there is a vector going in y direction and then it is j vector. There is another vector going in minus y direction. They meet at the origin. So this vector is minus j. This vector is j. Now at origin, they meet each other. So this vector magnitude is 1. This vector magnitude is 1. They meet at each other. Direction is opposite to each other. What would be the new vector? That will be j plus minus j, 0. Magnitude 0. But they have magnitude 1 because they are hitting each other and cancelling each other. If vector is coming like this and they are meeting head-on collision, they are cancelling each other. If vector is coming like this and they are colliding, then they are cancelling each other. Little bit will remain. If they are coming at 90 degrees, they are cancelling each other again. Okay, little bit remain. If they are both are coming from same direction, then they are actually adding to each other. So if someone is coming in perpendicular to each other, their power they are cancelling. Okay, since they are not along the same direction, they are cancelling each other's power. That's why it is not 2, a square root of 2. A square, what happened to a square 1, 2 minus a square? It should have been 2, 1 I plus j, 1 magnitude 2. But it is square root of 2. 2 minus a square root of 2. Where it went? It went because of they cancelled each other. They were not in the same direction. This is vector fundamental. What would be their direction? Okay, understood. So 2 minus a square root of 2, the amount is gone because of cancelling each other. In that sense, what is the direction of new vector? I know the two vectors who combine each other, one is I, one is j. What is the new direction of the vector? That is I plus j. What do you mean I plus j? How much angle it is making with the how much angle it is making with the I x axis? Okay, then whatever you receive I plus j cos theta. What is theta? Okay, I understand it is a kind of cos theta, but what is theta? Okay, that is under question mark. What is theta? Okay, there can be many ways someone would prove it. What is theta? If there is a, if this is a, there is a vector I plus j, then I can consider there is a point called 1 comma 1 and they pass through. What is position vector? Position vector is nothing but if I have a point in xy plane and I draw a line from origin to that point and make an arrow, that vector is called position vector. If I have a point, if this is xy plane, there is a point called x comma y. From origin, if I draw a line like this, passing the x comma y, then that is the position vector of x comma y. Okay, that is xi plus yj. Similarly, if I have I plus j vector, then it is touching the point 1 comma 1. That means vertical is 1 and horizontal is 1. Now angle is tan inverse 1 by 1, that is 45 degree. It makes 45 degree along the x-axis. Okay, what is the, now this vector I now understand it has power of a square root of 2. What is the essence, what is the, if someone is standing on x-axis and there is an energy passing like this, how much energy he is feeling along x-axis, how much energy he is feeling along y-axis if someone is standing here, like a wind is blowing like this, wind is blowing in this direction, a person standing on x-axis, he is feeling the wind, y-axis he is, how much he is getting when the vector is I plus j. Okay, then it is, if like this, then this, whatever the strength is of this vector, cos theta, whatever of the strength of this vector, sine theta, that much is the energy someone is feeling here and here. So you are saying, if I say I plus j, then if someone is feeling energy on along this direction, then this is one energy source, one energy direction, one energy direction. If these two energy direction met, then this energy direction met. It can be understood in this fashion also. So I plus j, the I plus j, that strength is the square root of 2. Square root of 2 cos theta, cos 45 degree is 1. So he is feeling energy along x-axis as 1. 1. Looks like there is a two energy source. One is I, one means I, j, that met and become I plus j, certainly. So both way are true. If I have a energy that is I plus j, then its x component is I and y component is j. How we can say that is I plus j plus j. One is I and one is j. You just added it. So x component is I. So it looks like there are two energy sources. They met each other and they form this vector. Please do support us. Okay, this explanation probably you will not find anywhere else. +91 is the India country code. 94831 60610 is the telephone number. 94831 60610 telephone number, +91 is the India country code. Please do support. Okay, so this is the concept of vector. Vector is nothing but combination of energy moving in orthogonal direction, 90-degree direction. One is x-axis, one is y-axis, z-axis, whatever. If that is the case, if I have machine learning samples against a feature, I drew a set of features and then I have a sample which has value against the feature, then feature can be considered as orthogonal components and sample has value against the orthogonal component. Sample is a vector whose components are features against this feature. So consider I have feature at x, y, z, x-axis, y-axis, z-axis. Now I have a sample where x is 2, y is 3 and z is 3. You would say this is a point. If I have x-axis and if I have, this is y-axis, this is x-axis and this is z-axis vertical, this is y-axis, z-axis, this is x-axis. If I take any point x comma y comma z 2, 3, 4, then I can represent as a machine learning sample 2 comma 3 comma 4. Okay, then I can represent it as 2i plus 3j plus 4k. Next sample like that. Now, the way I am proceeding, that way you can start doing calculus on top of it. Okay, that is simple machine learning. Each sample is a vector. What is lacking here? The feature what we take, they should be orthogonal to each other. If they are not orthogonal to each other, then dimension reductibility and those kind of fundamentals comes. So that Ein vector and those things we start taking. So that Ein vector, all vectors of Ein vector, they are perpendicular to each other. So we try to get the orthogonal component against which what would be the component. because one component should not be dependent upon other. If one feature is dependent upon other, then changing one feature would change other feature, and it drastically reduces the prediction, whatever the prediction we are going to make. So it drastically change the situation. So make sure, have we, research is going on that if I have 200 features, how I can how I can change it into three features only, that is x, y, z. Means that much information only I need. Dimension reductibility. Anyway, that's why I say vector is the future. So now I have two vector, one vector and combination I plus j. Now someone would ask, if I have, I have a line. Consider I have a line. We'll talk about algebraic vector. So consider I have a line. What is the equation of your line? Equation of my line is y equal to x or x minus y equal to 0. What is the line then? Then that is again 45 degree. This is the line. Y equal to x is the line. It will go along. It will pass the point 1 comma 1. This is y axis. This is x axis. 1 comma 1 point it will pass through, and equation of this line is y equal to x. Okay, what about y equal to 3 plus x? Y equal to 3 plus x. Same line, it will be little bit offset. 3 offset along y axis is given. Now this is the line. Okay, what is the vector form of this? What is the vector form of this? What is the vector form of this? Okay, what is the vector form of this line when it is making interception on the y-axis at 3? What is the vector equation of line when it is making interception on the x-axis at 3? When angle is 45 degree 1, then it will become y equal to x minus 3. If it is making interception at y-axis at 3, y minus 3 equal to x, y equal to 3 plus x, x plus 3. Okay, what is vector representation? Vector always talks about position vector. Vector always talks about position vector. Position vector is a vector which passes through origin. So vector has magnitude and a direction. That direction is from the origin. That is called position vector, typical vector. But if you want a vector that will be like this, or vector that will be like this, not passing through the origin, that is not a position vector. That is called parametric vector. Parametric vector. So if I say my equation of the vector is I plus j, then it exactly represents y equal to x line. But if I have line equation is y equal to x plus 3, then I cannot say it is I plus j. If I want exact representation of that, in that sense, if I say my line equation is y equal to x plus 3. Now on this line, take any point here, that is x comma y. Then vector equation is, position vector equation is xi plus yj. Now if I replace y with x plus 3, y with x plus 3, it becomes xi plus 3 plus x j. This is called parametric vector. Actual vector is I plus j only. But parametric vector means this vector should represent the line exactly like that. Now that is xi plus 3 plus xj. When x equal to 0, when x equal to 0, then the point here is, it is 3j. When x equal to 0, at time when x equal to 0, okay, it is 3j. When x equal to 1, then it is I plus 4j. Makes sense, right? So the equation is, of that equation is xi plus 3 plus xj. Xi plus 3 plus xj. Okay, now when x equal to 0, this is the point where this vector is, parametric vector is. Now when x equal to 1, x equal to 1 is a variable, right? When x equal to 1, it is I plus 4j. I plus 4j. Okay, at that time, it I plus 4j means it would satisfy a point called 1 plus 1 comma 4. Then it will be here. First is here, first is here. When x equal to 1, 2, then it is 2 plus 2 plus 5j. Then here, If you draw this line, then that is a representation of vector line, that is y equal to x plus 3. This is called parametric vector xi plus 3 plus xj. This also represent a line. This vector also represent a line, but it is a function of x. This is called algebraic vector, a vector whose components are algebra xi plus 3 plus xj. This is called algebraic function, typically algebraic function. But anyway, we are in a mood to calculate the length of a curve. That's why we are introducing vector. We will see that. Okay, if I have a vector, okay, that is I plus j, or this represent a line that is y equal to x, then parametric equation of this vector is xi plus xj. Y equal to x means if I take any point on the vector and connect from the origin, the position vector is xi plus yj. Xi plus yj. Now consider that this represent a kind of velocity of a function. Person. A person has x is time graph. X is time graph, and y is the distance he is covering. The distance he is covering, kind of, at any time, what is the distance he is covering from the origin. This is interpretation, what we interpret. So I have a vector called xi plus yj, xi plus xj, where x is time. Okay, x is time. Okay, if x is time means ith, this vector is addition of two energy. One is energy is x and its direction is I. One energy is x again, but its direction is j. Okay, the ith direction is time vector. The energy is time, whereas jth direction, the energy is distance from the origin he has traveled. So xi plus yj, xi plus yj. I mean y equal to x, right? That is the line. So line, the vector that is representing the line y equal to x is xi plus y xj. Now, I am trying to find, this is position vector p. P equal to xi plus xj. What is dp by dx? This is the calculus we are introducing. Calculus we are introducing in algebraic vector. What is dp by dx? If this is p, if this is p, this is the vector, this is p, which is combination of two energy vector. One is along I axis and its strength is x, that is x axis. One is along j axis, its strength is x only, wherever it is. Okay, xi plus xj. What about at any point x? If I move one unit, then how much I change in c in position vector dy by dx in algebra. If this is the height, that is y, this is x. At x, this is the height. At x, this is the height. If I move one unit along x-axis, then how much difference I see in the height dy by dx. If I move one unit, then how many unit y changes dy by dx. dp by dx. dp by dx. dp by dx. If this is position vector and position vector is xi plus yj, how much this position vector is changing at any point x when I move one unit up in x. dp by dx. P equal to xi plus yj. What is position vector? Position vector has two things. One is magnitude. A vector has a magnitude and its direction. Both would change. Both would change. So right now, if I have a position vector p, xi plus yj, its power is x square plus x square square root of 2. Square root, that is 2x square square, that is x square root of 2. That is the magnitude of this vector. Direction of this vector is xi plus xj divided by x square root of 2. That is I plus j divided by a square root of 2. This is the direction of this vector. dp by dx. If I change one unit along x-axis, how much p would change? P would change in its strength. This p is combination of two vector. One vector is along x-axis. One vector is along x-axis and one vector is along y-axis. The vector is along x-axis, it has some power and direction. Vector that is along y-axis, it has some power and direction. Okay. Now, if I am saying xi plus xj dp by dx, then it is combination of two vector and plus means we can differentiate directly. Plus has no any special rule and regulation. Dp by dx is nothing but change dx component by dx I plus dy component by dxj. Okay, this means that whatever vector we had along x component, if it is xi plus xj, its x component is xi. How much this x component will change when I do one unit change along x axis? That is 1. 1. What is x component? X component is time. So dp by dx, if I consider p as x-axis energy combination of x-axis energy and y-axis energy, then x-axis energy would change 1 if I make 1 unit change in x. dp by dx, x component, that is dx by dx. So net will be I plus j. dp by dx is I plus j. Indeed, the both vector we are talking against which combination is xi plus yj, they would change 1 unit along x-axis and 1 unit along y-axis if there is 1 unit change in x. That is the new vector that is coming into the picture. Earlier vector was xi plus yj, that is position vector. Now dp by dx is called velocity vector. Velocity vector in the sense changes happening with respect to x. Now velocity vector is again direction I plus j. Velocity vector, that is I plus j. Earlier xi plus y. What is the direction of velocity vector? That is again I plus j divided by square root of 2. Same. This proves that if I have a straight line, if I have a straight line, its derivative vector is this vector's derivative is along the same line, but magnitude is constant now. The velocity vector that we are talking is, it has magnitude of a square root of 2. Okay, that is velocity vector. So what is velocity vector? Velocity vector means in x component, if I had taken the vector xi plus yj, then distance what we saw is the yth component, jth component, that is x. Time what we are saying, that is energy vector, that is x, xi, xj. Now how much velocity it is gaining, that is the second component, that is 1. Means if I make 1 unit of change in x, 1 unit of change that will be seen in distance. Okay, means velocity is 1. Now again the velocity vector, that is the time vector differentiation plus actual distance vector differentiation, if I add to I plus j, is called velocity vector. How much p is changing? So p is, I say if this is p, if this is p, then if this is p, then dp by dx is also in this direction only, but strength is different. Strength is different, direction is same. If you are talking like that, I have a circle. If you are talking like that, I have a circle. Circle means what? Circle is centered at the origin. Circle is centered at the origin. Now, if that is the case, then this is time graph. This is 0 and time continues like this. This is minus time in past. And this is the distance person is covering. So when timer begins at origin, person is at some distance already. He is at some distance already. If this time is crossing the clock, it tick 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 it is doing, then person is coming back, and at this moment of the time person is coming to the x equal to, coming to the y equal to 0, means he is coming back. At the beginning person is at some distance and he is coming back. At what speed he is walking? Means he is not walking continuously. I mean, he is not walking in linear fashion. If he was walking like linear fashion, means his speed is linear. Linearly, his speed is linear. then at the beginning he is at distance this much. If he is walking linearly, then at this time, then he came to origin, then the direction will be like this. When when he is not walking linearly, then he is walking like this circularly. Means at origin he is at this distance this much. At half of the time, if I consider this length as the time he took, then half, if this length is a radius of the circle, then at half of the time, his height means distance from here is not half. It should be half if he is walking linearly. So at the beginning, his speed is less. It looks like flat line, but slowly it is like a vertical line. Then at the end, he walked little fast and it came to rest. This is time distance graph. Time distance graph, if I take, then at any moment, what is the position vector? If I take any moment as x comma y, then position vector is xi plus yj, where x is the time vector, time energy vector, where y is the distance vector. They are combining each other and making the position vector. At the end, this line is the combination of x and y, right? That is time and distance combination is this line. Okay, we are trying to find the length of this line. If someone is walking in a circular fashion means he's not walking circularly. Circular fashion means at any moment, at what distance he is, that depend upon the this height at any moment. It is not linear. That's it. So if I take any point here x comma y, then what is the position vector? Xi plus yj. What is y? X square plus y square equal to a square. So y is the square root of a square minus x square. So position vector is xi plus square root of x square root of a square minus x square j. This is the position vector of this. Okay, now what is the velocity vector? What is the velocity he is gaining if he is walking like this? What is the velocity he is gaining? Okay, if he is walking like this, what is the velocity he is gaining? If that is the question, then velocity that he is gaining is dp by dx. If there is change in time, then what is change in the vector? I'm not talking about what will change in the distance. Change in the vector. Vector is combination of time and distance, both. That is difference between vector and dy by dx. dp by dx. Change in position vector when there is change in time, x-axis, dp by dx. So if dp by dx will again be a vector, p is a vector, dp by dx is a vector. New vector will have is different because it has different magnitude and different direction. Okay, so if that is the case, then dp by dx is I plus minus x by a square root of a square minus x square j. Okay, earlier, what was the magnitude of earlier vector? That is xi plus square root of a square minus x square j. What was the magnitude? X square plus a square minus x square square root square a. Exactly right. Means position vector, the magnitude of I take of this vector, position vector, the strength is radius only, distance is radius only, that is a. What is the magnitude of new vector? That is I plus minus x by square root of x square minus a square minus x square j. 1 square plus x square by a square minus x square. If I do, settle it down, it becomes a square by a square minus x square square root. A would come out a by a square root of a square minus x square is the magnitude of the vector, not constant. Velocity vector is not constant. Velocity, okay, the velocity vector is not constant. Or if I see in the vector representation that first was xi plus square root of a square minus x square j. What is the unit vector? Then it is xi plus square root of a square minus x square j divided by a. That is the strength of the vector, that is the unit vector. Strength of the vector is a. What is dp by dx strength? dp by dx strength, one is I, one is minus x by square root of a square minus x square. 1 square plus x square divided by a square minus x square. Okay, the strength is a by a square root of a square minus x square is the power of the vector. Okay, what is the unit vector then? Unit vector is I plus minus x by a square root of a square minus x square j divided by a by a square root of a square minus x square. This is what I think so. Okay, I'll try again calculating the magnitude. I plus x minus x by square root of a square minus x square. 1 square plus x square divided by square root of a square minus x square. Correct. So this is both are different. Means if I have a curve and if I calculate dp by dx, direction will be different, magnitude certainly will be different for dp by dx. If it is a straight line, then direction of the velocity vector will be same as direction of the position vector. But if it is not a straight line, then it will be different. What it is? Question arising is what it is. What the direction of the what is the direction of the new vector if it is not a straight line curve? dp by dx, how much position vector is changing? Now I talked about direction changing and magnitude changing. If I talk about how much is the velocity as far as covering the distance is concerned, then you have to think about the y part. Then the velocity is minus x by square root of a square minus x square. At every moment of x, velocity is changing. Can you see it? Every moment velocity is changing. If it is a straight line, earlier equation, velocity was a constant I. That person was working in a constant velocity. Now velocity is changing everywhere. If he is walking like this in this curvial equation, so velocity is changing, whatever it is. It is minus x by square root of a square minus x square is velocity. Means velocity is reducing. Okay, means that person is velocity is negative. Means he is decelerating. Means he is coming to rest. He is we were at some distance. He is coming back to the. If he is going like this, then there will be some velocity. Coming back, then velocity will be. His negative means opposite direction. He is coming back. That is why velocity is negative. Very perfect, right? It's perfect. What is the direction of velocity vector? Direction of velocity vector, someone would compute I plus minus x by square root of a square minus x square j. Depend upon the x. Depend upon the x, the direction of velocity vector would change. Okay. What about direction of velocity vector when x equal to 0? Means at this point, then it is I. This is the direction of velocity vector. What is the direction of velocity when x equal to a? Then minus a by a is 0. J component is infinite, x component 1. Means more or less direction of velocity vector is minus j. Means it is in infinite means it will be in j direction. X component is negligible. So exactly looks like it is tangent. Can you see? If it is looks like it is tangent, can I do dot product of these two? Position vector and dp by dx vector. Position vector is xi, xi plus yj. Here it is I minus xyy. Square root of a square minus x square I can consider as y only. J, if I do dot product, then it becomes x minus x, 0. Means they are orthogonal to each other. If I had a straight line, they had same direction, p and dp by dx. If it is a circular or curve, then it is perpendicular to each other. Okay, I think too much time is there. We proceed on this with these fundamentals, how I can calculate the length of a curve. If I say I want length of this full circle, how I can calculate? Because vector I have to use because vector has combination of x and y component both. dy by dx will not work because it gives only y component which change on x. So dp by dx will work because it thinks about x component and y component both. And if I want the length of this curve, then I have to think about both because length of the curve means there are many points connecting and making this curve. All points represent x comma y, both component, time and distance component, both component are there. Okay, so this is the base and I believe we will talk more on it. Please do support us. Plus 91 is the India country code. 9483160610 is the telephone number. Plus 91 is the India country code. 9483160610 is the telephone.